Hello students, I am Dr. Sanjeev Punia. This is the last and fourth unit of computer graphics, that is three-dimensional viewing. There are different topics like introduction, representation of 3D object, then projections and different type of projections like parallel projection, perspective projection, orthographic and oblique projection, then cantilever and cabinet projection, and in the last we will discuss about clipping, and in clipping we will study Cohen-Sutherland clipping algo. So this was the overview of fourth unit, that is three-dimensional viewing. In today's class, we will discuss about the introduction of 3D viewing and how we can represent the 3D viewing and what we have to study in this unit. So let's start from three-dimensional viewing today. As in our day-to-day life, whatever we are seeing, that is called 3D real viewing. Means how the object we are seeing. For an example, this is a object. When I want to see this object using a camera, then it will look like this one, where it has three-dimensional, that is X, Y, and Z. Means there are three-dimensional when we look a real object using camera or our eyes. For an example, I am taking another object. This is the object 2, that is his jar. This jar also have three-dimensional. When I take the I take the photo of this jar from this side, from the upper side, as it also showing X, Y, Z, means all the three axes. But when I want to represent this, or I want to take the photo of this from front side, from this side, or from this side, or from this side, then as the handle of this is in this side, suppose I want to saw this object from this side, then I cannot see the handle of this kettle at all. Whatever I am seeing, that is this one. That is this one. Means this is the complete image I can see, and you can see from here that it contains two directions only. First one is this and second one is this. When I want to see this object from here, then you can see that in the right hand side, I am seeing the handle of this also. So it will look like this object. And here also you can see that there are two directions, that is y and x directions. When I am seeing this object from this side, then as the handle is in between, then we can see that this is the handle, this is the handle, and this is the image of rest of the cattle. But I am not able to see the depth of this. So from here also you can analyze that we are able to see only two dimensions. That is, first one is this, and second one is this. First one is x direction, and second one is maybe y direction. So in the real, we have to represent the things in two-dimensional. As we discussed earlier also, that whatever we are seeing from our eyes, that is a three-dimensional object, but we cannot represent that object on our display, as we know that the display is of two-dimensional. Here you can see, as we are using the display also to understand this, whatever I am teaching you, we are studying this on the display also. You can see from your computer screen that it has only two directions, that is x and y. This is y direction and this is x direction. So, and over here, when we see the things using our eyes or using a camera, then this is a 3D object. This is a 3D view. But we have to represent this 3D view on 2D. So there are different steps to perform this operation, as we discussed earlier that how we can convert a word space into window space. Means conversion of word to window or window to word and from window to viewport. So we discuss all these things. Now we are starting in this unit from camera space, as we discussed in last slide that whatever the object we are seeing, you can see from here that this is a object we are seeing from the camera and it has three-dimensional. So this is the reason that we have to convert this three-dimensional object in 2D, and there are different steps to perform this complete process. We study that how we can convert a 3D model into word space, then word space to window space, and from window to viewport. So we studied till here. Now in camera space, as this is also a 3D object over here, so we have to perform some operation on this to take the projection, to take the image, as we discussed in object 2 on last slide, that is object 2. So over here in this unit, we have to understand about the projection. We have to study about the projection. So we will see that what we can do in projections and what are the different type of projections we can perform to convert a object from camera space to clipping volume space. As this is also the second part, clipping is also the second part of unit 4. So after the projection, we will study about the clipping also. In this, we will study about the projection only at this point. So this was about the introduction, that what we have to do and what's the purpose and process, what's the need for that. So our purpose is to display a 3D object on display a 3D object on 2D object, and this is called a picture plane. This display or a plane where we display the image, that is called picture plane, image plane, or sometimes it is also called projection. So through this diagram, we will try to understand the concept of transformation. You can see from last slide that over here, these operations we are performing on vertex, and this is different, that is rasterization we studied in unit first, like DDA algos. So this all has to be performed vertex by vertex, means on all the vertex. But the thing is that the operation is going to perform pixel by pixel, pixel by pixel. For an example, we have to project this object, this 3D object on a projection plane or on an image. Then we have to perform operation one by one. First, we will perform the operation on this pixel, then we will perform the operation on this pixel, then on this pixel. Means whatever the operation we have to perform, the basic operation we have to perform on pixel, and after that we perform that operation for each and every pixel of that image. So to understand the concept of transformation, we have to understand the basic, that is about the one pixel only. This is the thing we can repeat for each and every pixel. So when we have any point on this object, as this is a 3D object and there are 3 axes, so there will be x coordinate, y coordinate and z coordinate of this pixel or this point of the object. Now, when we have to represent this object on a plane where the plane is based on only and only two axes, that is y axis. There is no z axis over here. Then the image of the object have only and only two coordinates. This is for x axis and this is for y axis. So what happened with the coordinate of z axis? As I told you, there is no z axis. So in that case, the value of z axis has to be changed. So in this case, when we have to perform this, then value of xv means value of x on x image axis will be same. Value of y on y image axis will be same. This is also same. What happens only third, that is z axis. The value on z axis becomes 0 instead of z. Sorry. So when we have to perform any transformation, in that case, only the value of one axis, maybe sometime it will be x-axis value will be 0, maybe on another time the value of y-axis will be 0, but the concept is this, that from three coordinates the value of one coordinate is 0, means we have to represent that using two coordinates only. And when the value of this coordinate is 0, then we cannot represent, or there is no need to represent the z coordinate value. So we have to represent this xyz in xy. So this is the basic concept behind this, and this is called the transformation equation. These are called the transformation equation in projection. Let me try to tell you by a real example that what happens when we want to see a 3D object and what is the projection. As this is an object, this is an object, and this is a light source. A light source means from where we have to see. Or you can understand that this light source is a human being, from where this object has to be seen. A screen is behind the object where we have to saw the object. As there is a object between the wall and me, and I want to see that object, then whatever I can see on the wall, then that is called the projection of that image. As when we want to see that this screen is called the projection plane or view plane, and this is the projection center, means from where we are seeing or the object or we are putting the rays, or we are sending the rays for the object that is called projection center. First, I will discuss about that how this lower axis, how this lower level or this edge will be shown over the screen. I will try to tell you first that when we will see this below edge of this object, then how it will be represented in 2D on the view plane. So first we will see only and only about the lower rays. So from here you can see, if you will pay attention over here, then all the light rays or all the rays are coming at this side of the object. All the lines, these are also called projected lines, are coming from this light source towards screen. So when these rays will touch on the object at this point, then this will look like a line. This will look like a line on the screen. When all the rays are going to project from the one edge that is below edge of this object, then this is the projection of this object on this. Keep in mind that we are seeing the projection of edge by edge. So first we are discussing about this lower edge. Now we will see that when we will project this one, when we will project left edge of left vertical edge of this object, then how the image of this object will going to represent on screen. So from here you can see that this is the line as we saw in the last slide. In the last slide, in this we are discussing about the image, about the projection of this left vertical edge on the image. So it will be what is happening. Yes, we want to see the projection of this edge, and the projection of this edge will be like this. Now we will try to see the projection of this one. Then in that case, the projection of this will look like this one. Okay, first I will tell you the projection of this one. Then after that we will discuss the projection of this edge. So let's try to understand the projection of this edge, that is right hand vertical side edge, and we will see that how the rays are going to be project on the screen. So this is the edge for which we want to see the projection on the screen. So these are the lines, those start from the light source, and these are touching to screen at this position. So this is the image of this line only. Now we saw in first we saw that how or what will be the image of this, then we discuss the image of this one, then we discuss about the image of this one. Now we will see that how we can see the projection of above edge. So to understand the projection of above edge, when the rays are going to start from this light source and we are seeing this up, sorry, not this one, this upper edge, then rays start from here, and after passing from here it will strike, at these lines. It will strike at these lines. So this is the projection of upper edge. This is the projection of lower edge. This is the projection of right edge, and this is the projection of left edge. This is the left edge, and this is its projection. And the projection of right edge is this. So this is the way by which we can see the 3D viewing on 2D space, that is on the view plane or on screen. So this is the basic concept behind 3D viewing on 2D plane. Now, how we can see the image of an object? There are two different ways for that. Suppose this is an object, this is an object, and from here we want to see the image of this object. This is also called the projector. From where the line starts, it is called the projectors, and these are the line of sight. These are the line of sight. Those pass through the edges of these objects. So one thing that I can see the image of this object on the behind of that, on the behind of that, as this is the object, this is the image of this object as we discussed, in the last slide. So this is the image of this object. So in one case, the plane, the projection plane, the view can be behind the object, and in another case, the projection plane can be front of the object. As you can see that this is the object, and this person is trying to see the image of this object on this plane. As this is before the object, so the images can be obtained either on the right hand side of the object, or we can say that when there is a projection point or viewer, then the image of that object can be on both the side, so this is about the image, that how image can be formed on 2D plane. Means it can be on the front side or in the back. And in the last of this, we are try to understand about the projection, as we saw that all the images are formed by the projections of lines through the object. So we have to understand that what is the projection. So basically, projection is of two types. The forming of image, as we saw over here, this is the object and we want to see this on projection plane, then this is the view of the object. This is the view of the object. Then to see these views, there are different ways. There are different ways, but whatever the image is going to be formed, that is because of these projection lines, and the projection of making an image of an object is called projection. The process of making an image of a object is called projection. So basically, projection is of two types. First one is parallel projection and second one is perspective projection. For an example, in parallel projection, the rays are start from the infinity, means only and only we can see an object. Suppose this is an object and we want to see the image or projected image of this object on the projection plane or on the plane, then it will look like the it will look like the same, that is of same size, or the projections lines are parallel. When this object is going to see from the infinite position. So when the center of projection is at infinite, then all the projector lines are parallel to this object, and this is the image formed by the projection or the parallel projection. You can see from here that size of this and this image is same, or you can say that height of this object is same as the height of this image. But in case of perspective projection, there is the center of projection that is nearby, means the projection rays are not parallel to each other. you can see from here that these two projectors or these two projection lines are parallel, but these two are not parallel. Means it is going to see the object from this point. This is the object. As I told you that image can be on both sides. It can be in the front or it can be in the back. So we are seeing the image of this object in front side on front project plane, and this is A dash B dash on the projection plane. And you can see from here that the height of the object is not same as the height of the image. Means in perspective projection, the shape of the image is going to be changed, but it is not the case in parallel projection, as the range in parallel projection starts from infinite, and in this the rays are not going to start from infinite, that is from a definite point. And COP, as I told you over here, is an arbitrary point where lines are drawn on an object. You can see this is the center of projection, center of projection. This is an arbitrary point. This is a point from where we will draw the lines in on the object. So this is one line, this is another line. So all other lines are also drawn from this point. So this is the center of projection. This is called COP. So in this we discuss about the projection, that what is the projection. In today's lecture, we discuss that what is 3D viewing, what is a 3D viewing, as in 3D viewing there are three coordinates x, y, z of an image, and when we have to represent that in 2D as an on the display, then we have to convert the object from 3D to 2D, and this is the transformation equation, that is z coordinate becomes 0. Now we saw that what's the different type of views we can see of an object. We discussed that how we can see the bottom edge, how we can see the bottom edge, projection of bottom edge, projection of left, projection of right, projection of top edge, and this is the image, means how the image of an object is going to be formed or how it is going to look at the view plane. Then we discuss that images of an object can be formed on both of the sides, that is in front of the object over here and in the back side of the object. Then we discuss about the projection. There are basically two type of projections we are studying over here, that is parallel projection, where the COP is at the COP is at the infinite, and in perspective this is at the distance, and COP is called the center of projection, that is arbitrary point from where all the lines are drawn on the object. So We will discuss projection in detail in the next lecture. I hope this all will be clear to you and there will be no doubt. So we will discuss projection in detail. Thank you.